Okay, so you're ready to do the lab. Great. Here's what you're going to need to know to do the lab. First, you need to find the percent error between your calculated mass and the accepted value that's on Google Classroom. If that number is greater than 10%, you need to redo the lab. If it's less than 10%, we can start to move on. Okay. So our first step is we're going to be doing the over-under method to really take a look at our uncertainty and our error in this situation. So the first thing we need to do is we need to justify any uncertainty in our values. What values did we measure? We measured angles, so we need to find our uncertainty in our angle. So what you'll think about when you put your protractor on there, okay, is, oh, it moved a little bit. So what you're going to do is you're going to put your protractor on there and you're going to measure your angles. So maybe my angle's 55 degrees. Now with this protractor, I'm able to measure within a degree. I'm pretty sure it's 55, but it could be 54 to 56. And that's pretty liberal with this protractor. You are using much better protractors, so your number should be a lot less than 1 degree. Now, I also was making marks behind these. My board actually moved a little bit on me, but that's okay. So I made marks behind these. And I want to figure out, well, how much could I have made those marks off by? Well, maybe I go back to my board, I make another mark, and I say, okay, I'm looking at that, and those two marks are pretty darn close to each other. Maybe they're off by half a degree for me on a board up here with markers. Okay, so I'm going to add those two together. So maybe I got a half a degree, maybe I'm off by for making my marks, and a degree for using my protractor, so I'm 1.5 degrees is my uncertainty. I've justified it. Okay, I've said I'm able to use my protractor to measure to this. The line is this thickness, which accounts for about this much of an angle. All right. Once you have your justified uncertainty, now you have to find your possible range, the biggest and smallest number. In order to do that, what you're going to need to do is you're going to need to take that uncertainty of 1.5 degrees for me, and I'm going to add it to some of these and subtract it from others to get the maximum error I could have using that uncertainty, or the maximum mass I could have. So how we figure out what to add and subtract is I essentially pretend like this is heavier, and I think about what happens to my angles that I measured. All right. So if the string gets more vertical, that angle's getting bigger. If the string gets more horizontal, it's getting smaller. So as I pull this one down, this string gets more vertical, so I'm actually going to add here. As I pull this one down, this string is getting more vertical, it's getting less horizontal, so that means I'm going to add those as well. And then this string, as I pull down on this one, that string gets more horizontal, so it gets less vertical, so I have to subtract. And so I will take that uncertainty I have in my angle, 1.5 degrees for me, I'll add 1.5, add 1.5, add 1.5, subtract 1.5, redo my calculations, and that will get me a high mass value. I want to do the same thing for low, it's going to be the opposite, so minus, 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 plus. Okay. Once I have my high and my low value, I'm going to take the difference, high minus low divided by 2. This will give me an uncertainty in my mass that I calculated and used for my percent error. All right, so we're going to take our uncertainty in our angle measurement and get an uncertainty in our mass value. All right, so now what we're going to do with that is we're going to take our calculated value from before, the accepted value from Google Classroom, take the difference, absolute value, and divide it by this uncertainty. Essentially, we want to see within how many uncertainties is the accepted value of my calculated value. Okay? And so we're going to get a number, and if it's within one uncertainty, so it's less than 1 for that number, that means that my uncertainty is the likely source of my error. I've justified a source of uncertainty, and my value, my accepted value, lands within that uncertainty. Perfect. Okay. Now, if it's between 1 and 3, this is kind of our gray area. That means there's maybe some other source of small error that you missed, or your uncertainty was too low. So these kind of go hand in hand. If you can go back and say, oh, you know, I forgot to account for the width of the string, go back and do it now. Go back and say, okay, the width of the string was about this much. On my angle, that would have accounted for this much. Redo the calculation. See if you get better results. See if you've identified all those sources of uncertainty. If you get 3 or more, that means there's other significant sources of error in your problem. And I would either try again, start over, or see Mr. Foster for help. This is your lab report. Make sure you turn it in early so you can get feedback on it, and then you can improve before the final due date. Go to work.